Hello, Drew. I was at lunch a while ago sitting in the restaurant when we were chatting back and forth, and right when you sent your last message I headed out to the pickup and been on the road for a few minutes. So I thought before I started chatting I would just make a quick little video. This is the tire hammer that's leaving today. We finished it not very long ago. Been sitting here a few days, and it's shipping off somewhere in Texas, and it's ready to go. The anvil is 36 inches tall. It's an 8-inch diameter piece of steel. If you want to calculate it exactly, it's about 8.125. It's a hot roll 1018. Base plate is 2 foot square, 1/2-inch steel. The column is 5-inch by 5-inch, 1/4-inch wall. Every once in a while we'll use a 5/16 wall or a 3/8 wall if we get a good deal on it, just because sometimes we can even get them cheaper, but for the longest time we've just been using 1/4 wall. And I'll show you a close-up a little bit later, probably another video where I'll pause this one of the ram. The ram sits right here, solid machined. And when we started building these, we built these off of the tire hammer plans, but made by Clay Spencer. And Clay copied the geometry of the arms, the spring, the DuPont mechanism here after. That's what's copied after the Little Giant. The drive mechanism, we've found historical evidence that tires being used as clutches, friction driven for 100 years. I mean, I've got a picture that's probably from the 30s or something, but Ray Klontz and Clay, they kind of worked on getting that together. In the first tire hammers that Clay built, we would take a spare tire, a temp spare tire, and we bolt the axle in place, bolt it down, spin it and get it right, and then we break the tire off the rim, squish it down, put wooden blocks under the rim, and lace it with wet towels. We cut out a circle out of 1/4-inch plate and drop in there, and we weld it, stitch weld it all the way around, and it's got the crank plate in it. Problem with that is once that was done, that was eternally sealed there. If your bearings went out, if you had a problem, if you had a flat tire, which a few people have, you had to break it down on the machine. There was no taking it off. And some people would challenge me on that, saying you could take it off. Well, yes, you could if you had a friend with a very small hand, a lot of patience. Anyways, it was a pain in the neck. And we kind of pioneered this, changed this new style crank plate. We built it separate. I could walk you through disassembling and reassembling that thing if you needed to change the tire. We have gone to using new trailer tires on here instead of the temp spares. There's no functional benefit of that. They don't work any better or worse, maybe a little better, but they're just more available, more consistent. We buy them new. And so all of that, we machined the ram out of solid steel on a CNC machine. And other than that, we do one small modification down here, the guide stop on the bottom. We've made it removable. That's just a minor convenience thing. It's okay. But we do a good job building the tire hammers. There are other builders that also do an excellent job of building the tire hammers. There are many that do a terrible job. And it's not that they set out to do a terrible job. Either they lack experience or funding or whatever reason. But we do a good job building these tire hammers. We've built a lot of them. A little over 300 of them. We build them here full-time in our shop in Agra, and then a couple of times a year we do build workshops. We've been doing them in Robert, Louisiana twice a year, but last year we only did one, and it's looking like we'll probably only do one next year. But we do them different places at different times, but this is a good tire hammer. I'm going to pause this. I don't know if I can pause this and restart it later, but this is an older tire hammer. It's not very much older. It's actually one of my prototypes of the first solid, the first new style crank plates that I built when we transitioned from the old style. And this was the original style lower guide stop. Inside of here is a UHMW is the bearing surface, and then behind that is shims that keep it in place. This one uses 3/16 inch thick UHMW, and then has shim stock behind there. And this ram, it is solid, it is machined. We machined the surfaces. Back when we did this one, we didn't have the big mill, and we did this a little bit different. Like I say, this was my prototype, and this prototype machine later, if you wanted to take the UHMW out, you would stick a screwdriver behind here, bend this out, pull that out. The front one came out really easy. The side ones, however, you can see it would be a little problem. People would say, well, you got to take that linkage off. Clay would always laugh, a little he, and he would pull it out of there, bending it like a banana. And when you get it out, it would be bent and curled up. He'd say it doesn't matter, and he'd put it back in that way. You can see that the back one, it appears it might be tough, but it's really not. It would come straight up there really easy. So the two side ones were hard to get out. And what we did was we weld coupling nuts. They take a 1/4 bolt. We weld them on here on all four sides, and we have a cutout guide that bolts on, bolts off. So if you want to take it off, you just unscrew the bolts off, all the packings fall out. You can change your UHMW or your shims if you need to, which, by the way, you don't need too often. And anyway, that was a improvement we made. This is a close-up of the new style crank plate in there, and I'm going to pause again. This is the new style. I've got the shield in place upside down for shipping because, well, if it's up here, it tends to maybe kind of get caught by the wind or something. But anyway, this one leaves soon. But this is that lower guide stop that's removable. We weld that little coupling nut on there, and then 4 bolts, if you can see, takes it on and off. And it has worked really well. We've been doing that for a few years. The brake, this is the brake system that goes on here. It's adjustable right here. Works really well. If you want to look at the back, there's how the tire, the rim is actually mounted backwards. This would be what would normally be on the outside. And then goes up in there. Friction drive here. And the motor mount plate. The 4140 dies. Now if you're coming from a big hammer, you know, that's kind of a small die surface for a big hammer, but keep in mind this is a smaller form factor. It's not meant to be the best at every range thing. It's a good price for what we can make efficient. So we try to do a good job. I'm going to pause again. Our shop's really messy right now. We're working on some machines right now. This is a CNC plasma table, another CNC plasma table. They'll both do oxyacetylene or plasma cutting. And over here is an Omax water jet. They're pretty cool. Here's another Omax water jet over here. This one's kind of down at the moment. I bought it out of a machine shop that was closing down. So if we go through the messy shop, over here, this is the mill where we make this is a blank setup to make the rams, and I've got one of the machined rams in my office in there. I'm fixing to ship out, and I'll catch that on video here shortly. But we make the rams in this Haas VF2. Okay, since I paused it, I've walked into my office where I do work as well. This is a machined ram. You know, the outside's obviously been milled. These are 3.9 by 3.9 square. We mill out this pocket up here and drill these holes right here. They're nicely drilled and reamed. That's the 4140 pins that goes through there to connect those. A customer who bought this is going to ship these out this afternoon. These are the parts for a crank plate. Made this. This is the beginnings of a crank plate. The big heavy parts is already boxed up in there, but anyways, I thought that might be of interest.